system of equations by graphing. And remember, a system, when we solve a system of equations, we're looking for one x and one y that'll work in both equations. And the way we did that was we graphed one line, graphed the other line, and looked to see where they cross. Well, it's kind of a pain. I don't know if you agree, but it's kind of a pain. It takes forever. So today we're going to learn another method called substitution. Substitute. I'm pretty sure a couple days ago you had a substitute teacher. Isn't that where you take out the real teacher and you plug in a new teacher in its place? Supposed to be equivalent. Doesn't look the same. Probably not the same, but it's supposed to be. I hear on TV about a sugar substitute. They call it Splenda. So in a recipe, you can take out the sugar and put in the Splenda. Supposed to be the same. It's supposed to make it sweet like sugar does. It's not exactly the same. If you're diabetic or something, it's better for you. So it's not exactly the same as sugar, but it's supposed to be the same. Makes it sweet. So would you agree a substitute, you take something out and you put something in its place that's supposed to be about the same? Well, that's what we're going to do today. We're going to substitute. This is number 3 on your assignment. Do you see up here, it tells you y equals this, right? It tells you what y is equal to. So we're going to substitute. Do you see the other equation here? This y right here. What is y equivalent to again? Y is equivalent to negative x plus 2. Those two things are the same. Y is equivalent to negative x plus 2. So down here, instead of that y, we're going to substitute. We're going to replace it with the thing that y is supposed to be equivalent to. Does that make sense? So down here, we're not going to put a y. What are we going to put in its place? We're going to put, right, negative x plus 2 in its place. So instead of this y, we're going to put negative x plus 2. And look at that now. How many variables do you have in this equation? How many? You just have the x. Shouldn't we be able to solve it then? You got to get all the x's together. I would add x. Is that what you would do? Positive 2 equals 3x. Now that I have all the x's together, you got to get rid of what's with it. How do you get rid of the plus 5? So what do you get? 3x equals negative 3. How do you finish her up? Divide by what? Divide by what? Right, divide by 3. And what do you get? X equals negative 1. Would you look at your paper and see what you got for x for number 3? Negative 1. Now, remember, you have to have an x and a y. So what we're going to need to do is go back to the one that we used for substitution. The y equals negative x plus 2. And we're going to substitute this back in. So y equals negative x plus 2. Y equals negative x. This x right here, what is x equal to? Negative 1. So we're going to put a negative 1 in place of x right here. And then we'll just work it out. What's minus negative 1? Positive 1. What's 1 plus 2? Would you look at number 3 and see what you got for y? 3. And I don't know about you, but I like this a lot better. It goes way faster. You would not have appreciated it. You would not have appreciated it. You would not have appreciated it. How about this one? How about number 8? Number 8, negative 2x plus y equals negative 1. And the other equation is x plus y. In order to use substitution, you've got to have either a y equals something or x equals something. Look at my 2 equations here. Do I have y equals something or x equals something? No, right? Well, if you don't have it, you have to get y equals or x equals. So this one right here, it doesn't matter which equation I use. I want to get y equals. How can I get y equals with this one? What did you say? Did you say add 2x? Because it's minus, so you want to add 2x to get rid of it. So what do you get then? Y is negative 1 plus 2x. Y is negative 1 plus 2x. So over here in the other equation that we didn't use yet, you see that y right there? You see this y over here? We're going to replace y with what it's equivalent to. We're going to replace the y with what y is equivalent to. X plus y equals 5. But what is y? What is y? Negative 1 plus 2x. So there's my x plus y equals 5. Does that make sense? And now, again, all you have is x's here. All you have are x's here, I should say. Here's an x. Here's an x. What's 2x plus another x? If I'm adding negative 1, can I just put minus 1? Do I have all the x's together? Add 1, add 1. So you have 3x equals, what next? Divide by 3. X equals 2. Am I done? You have to get the y that goes with it. Back over here, I would go back up to what we used to plug in. Y equals negative 1 plus 2x. What is x? What is x? 2. So I'm going to put a 2 in here. Y equals negative 1 plus, what is negative 1 plus 4? Now, I would like you to look at number 8 on your paper. Did you get x is 2, y is 3? Did you get x is 2, y is 3? A lot faster than graphing those.
So if you do this, you don't have to graph it.
Right, if you do this, you don't have to graph. And next week, we're going to learn one more way.
Is it easier than this?
It's about the same. It depends on the equations that you're given. So you're going to have 3 methods: graphing, substitution, and one more. And the idea is you can look at the equations and see which method would work best for which equations. But I'm pretty sure after this, you're not going to graph ever again. You're not going to graph to solve them because that takes the most time. You make one little mistake and everything's all off too, right? So, do you think you get the substitution method?
Mm-hmm.
Do you want to see another example?
No.
Oh, you got it. Okay. And one other thing about this, I think one of the problems that's somewhere in there, I did one of them last hour, it came out to be like a 30 for your answer. Well, can you imagine if you were graphing and one of the variables was 30? I got graph paper that has 10. 30 is going to be way up there or way over there, right? So this method will work way better than graphing. In a minute, I want you to give yourself 20 out of 20 if you did yesterday's assignment. You'll get just a completion grade if you did it. Because these took so much time and effort, I want you to get credit if you did it. Then your assignment is this. Are you looking? I want you to listen. Look up here and listen for 1 minute.
It's already up there, but.
Oh, it's already up there. Right. So, are you listening?
Yeah.
I don't think you're listening.
I'm listening.
All of these have whole number answers. There are none that are no solution. You should get an answer for every single one, and the answers are all whole numbers. If you get any fractions, that means something went wrong. So see me if you get any fractions. But all of these whole numbers, and there are none that are no solution. There aren't any no solutions. Got her, Otter? Anybody with questions? Are there any questions? Does anyone have a question? I guess not. Hi, Gracie.